sektörün değerli temsilcileri, değerli katılımcılar. Bir webinarla gene beraberiz. Webinarlarla tamamlıyoruz yılı neredeyse. Yılın son 4 webinarını, ikisini Kasım ayında, ikisini Aralık ayında birlikte düzenleyeceğiz, izleyeceğiz. Edebildiğimiz kadar bilgi edineceğiz. Ee, Önümüzdeki yılın da programın neredeyse yarısı hazır. Orada da gene yarı webinar, yarı seminer şeklinde devam ediyor. Ee, Program netleştikçe sizlerle paylaşacağız. Son eğitimimiz 22 Ekim'deydi. 22 Ekim'deki konumuz fabrika kurulumu esnasında dijital uygulamalar için öngörülen altyapı ihtiyaçları nelerdir? Bunu ENOSAT kuruluşuyla birlikte düzenlemiştik. Bundan sonraki webinarımız ise 26 Kasım'da. Orada da hassas döküm teknolojisinde 3D yöntemlerinin kullanımı. Hassas döküm çok nadiren e, düzenlediğimiz webinarlardan birisi. O konuya ilgisi olan, konuda bizzat çalışanlar için ilginç bir webinar olacağını düşünüyorum. Şimdi bugünkü webinara geçmezden önce kurallarımızı tekrar hatırlatmak istiyorum. Chatbox var. Aşağıda sohbet kutucuğu. Sorularımızı oraya yazacağız. Sunum sonunda ben soruları sen konuşmacıya soracağım. Gene sunum bittiğinde bir anketimiz var. O anketi cevaplandırmayı lütfen unutmayın. Onun dışında mikrofonlarımız kapalı. Kameralarımız isterseniz açık, isterseniz kapalı. Tamamen sizlerin tercihine bağlı. Şimdi bugünkü konumuza özellikle Türkçe'ye çevirmedik. Türkçe'ye çevrildiğinde e, bazı anlamlar kayboluyor. Özellikle ekranda göreceksiniz. Ama bu sunum sonrasında arzu edenler bu e, sunumun kopyasını edinebilecekler. Konuşmacının buna izni var. Ben şimdi sözü sayın konuşmacıya bırakıyorum. Konu hepimizi ilgilendiren Generation teknoloji and Digitalization. Bize bu konuda Sayın Doktor Ralf P. Jung sunacak ve devamında İngilizce olarak bir sohbete devam edeceğiz. Mr. Young, microphone is yours and I will ask you first introduce yourself and I have already announced that copy of the presentation is ready to be shared with the participants. Thank you.
Thanks a lot for the introduction, and thank you for giving me the opportunity to present our digital sand reclamation process to the Turkish foundry community. My name is Ralf Paul Jung. I'm 61 years old and have been educated as a chemist in the UK and in Germany, and got a PhD from Aachen University in Germany in the 1990, so some years ago. And 2 years later, by chance, I joined the foundry industry as a consultant and have been working there for more than 30 years now. My connection to RESAND, where I'm currently a member of the board of directors, the only German in the board, the only non-Finnish in the board, actually, was about 5 years ago when the company contacted me as a consultant to see if the solution they have developed for sand reclamation could be of any use to other markets than Finland. So I would like to give you an introduction about what we do and how we do it. And then you can probably judge on if there's any use for that technology and our business approach in the Turkey as well. Got a little bit of sore throat, so I might have to take some water in between. The table of content is basically why are we doing what we are doing? It's about circular economy, basically, the history of our company, our technology, the solutions we have, and what's in for you in that solution. The basic drive for our mission is the shortage of sand. The world is running out of sand, and especially here in Middle Europe, the sand costs for foundries are rising because sand mining involves quite a lot of energy for the classification, and within the European Union, the disposal of waste sand becomes more and more difficult and expensive. And of course, it's not really sustainable to take the sand from the pit, use it once, and then throw it away on a landfill. Sand production and transport have a large carbon footprint, and more of the foundry customers demand the foundries to reduce that carbon footprint. RESAND's mission is to enable foundries to reuse their sand and close the foundry sand cycles. So we have about 50 billion tons of sand mined every year, and this is a limited resource. We see high carbon emissions for the production and transportations, and an increasing challenge for foundries to dispose waste sand. In some countries, like in Spain, this is going to be banned in the near future. Therefore, we believe that reclaiming the sand in the foundry is the most sensible solution you can have. Why do we do what we do? The company RESAND's former name was Fin Recycling, and it was a scrap dealer. And when Tony Vezin, the founder, was delivering scrap metal to a Finnish foundry, he was asked if he could help with the sand as well. Because in Finland, you don't find quartz sand in high quality. Most Finnish sand contains a lot of feldspar and therefore has a low very poor thermal properties, and it can't be used in a foundry. So the Finnish foundrymen have to import their sand normally from Belgium or from Germany, and then has to be put on a lorry, shipped to Finland using a ferry, which makes very expensive the virgin sand when it arrives in Finland. So RESAND was founded as Fin Recycling more than 10 years ago, providing metal recycling service for the foundries. And then after Tony was asked to do something with the sand, he had a chance by acquiring a former glass factory in Nutajärvi. This was going to be demolished, but he thought, well, it just has been closed down. There's a lot of equipment in that foundry, in that glass factory, which is used to treat sand. And so he decided to set up a cooperation with Aalto University and Finnish foundries to develop a sand reclamation process in Finland for the Finnish foundries, and with the use of that know-how the glass people had how to treat sand. When you look at glass, the main consumable for glass is quartz sand, of course. And for glass people, quartz sand is at least as important as iron for foundrymen. So there's a lot of know-how there, which I've never seen in any foundry, how to treat sand, what to do with sand, how to modify the properties. And with this know-how, the cooperation with university and Finnish foundry, in 2017, the first sand was regenerated at that former glass factory in Nutajärvi. 2 years later, in 2019, commercial deliveries to foundries from Nutayeva service center began. The idea was Finnish foundries are rather small. There was only one large foundry group, which you may know in Turkey because they had some foundries there, but they were not very successful. So most Finnish foundries are rather small. It's 80 to 120 people, and they need about maybe 2,000 tons of sand per year. So Tony thought it was a good idea to have a central service center at Nurmijärvi, which is about 1.5 hours drive north of Helsinki, between Helsinki and Tampere. Tampere is an old industrial site in Finland, and all the foundry customers are within 100, 150 kilometers radius. So they deliver their sand to Nurmijärvi. The sand is cleaned, and everyone gets his own sand back. In 2021, we started a cooperation with Freiburg University, mainly to develop the process for green sand reclamation. Freiburg is a leading university for foundry technology in Germany, and there we got some funding from the Finnish Climate Fund, so we could provide the university with a production scale equipment of ours, which makes it possible to do not only lab tests, but really production size lot tests under conditions which are quite similar to what a foundry really needs. As I said, most customers are quite near to Nurmijärvi service center. One is not, it's in Rahe, it's about 600 kilometers away. So even with Finnish road trains, it's quite expensive to transport the sand from Nurmijärvi to Rahe. So the Rahe foundry decided to take an own reclaiming unit at their site and test the sand there. We got our first customer in Germany, and at the end of 2023, we installed a machine in Krefeld at the Simpelkamp foundry, and the first customer in Spain, in the Basque country near Bilbao. And this year, we are expanding our business, have been expanding our business in Spain and Germany, have entered Italy. Now we've started France, and now we are expanding globally. And one country on our list as being one of the most important foundry nations in Europe is, of course, Turkey, because we want to build a global presence in sand regeneration, but we do not want to go to China. Or technology. What's basically the idea? Tony Vezin started the development together with 5 Finnish foundries. So we are not just an academic, it's not just an academic approach, but it was basically the foundrymen's demand. They wanted to have a continuously operating, easy to install automated systems, which need snow operators. People are expensive in Finland. And the quality of the reclaimed sand should be so good that it bears no risk for the casting process. Basically, the reclaimed sand should be ready for use in the core shop, mainly cold box core production. And the system should be able to treat the same sand hundreds of times, because when you always have to replace 5 or 10% of the sand, you will have to import again from Germany or Belgium, which your foundryman didn't do. So we had some border conditions for instance, the grain size distribution, which shouldn't be affected by the process. So what's basically the model, the molds, casting, pouring of the iron into the mold, cooling and unpacking, and then we have, in general, 70 to 90% of the sand can go back to the molds for mechanical processing. And normally, the fresh sand, the new virgin sand, is introduced into the foundry sand system by cone making. But if you get some new sand into the system, you have to take out the same amount of waste sand and put it to the disposal and landfill to keep the system as a constant filling rate. So our technology is basically about treating the sand to reuse it in the core shop. How do we do it? We basically use a twin drum system for thermal mechanical reclamation. The first step, the upper drum, the heating drum, is cleaning the sand with thermal reclamation. So everything and the binders and the additives, which are combustible, are burned in the heating drum. And then we have a dedusting and cooling in the second drum. But as you can see in the picture of the dedusting drum, there's a little bit more than just an empty drum. There's a lot of things in that drum which allow the sand to be in contact basically with other sand grains to clean the surface. So and a dedusting is in there as well. So we get a clean silica sand, which is ready for use again, but we don't grind anything. So we do not affect the grain size distribution apart from taking some fines out with the dedusting. And then you see the reclamation units which we have. There are two different sizes available. We have an all-electric reclaimer with a capacity of 1 ton per hour approximately, and we have a bigger gas-fired reclaimer with 2 to 3.5 tons per hour. But of course, you can put 2 or 3 of the electric reclaimers in parallel if you don't want to have, if you don't want to use gas, which some of our, especially German customers, want to do because they don't want to have any carbon production in their system. So let's start with the small electrical reclaimer. We have basically a completely digital controlled unit. It's electrically heated, but it's not just heated, it has temperature zones with an electrical heating capacity of max 250 kilowatts. But the zones and the regulation is basically done by constantly measuring what's going on in that system, not only in the system, but as well the exhaust fumes which are coming out, because we have to control the residual oxygen level. There's a lot of process control involved in that to get the proper sand cleaning conditions to acquire the proper conditions for the reclaimed sand. This electrical machine is rather small. It's 7. When you play it in an eye layout, it's about 10 meters long, including the dedusting unit, and then 2 meters wide. You see the block on the lower block is 2 drums. Then you have the feeding silo and the dedusting unit on the side. And what we basically do with that is treat mainly chemical bonded sand for smaller foundries like Furan or Alphaset or anything like that. We can do about 2,000 tons per year with that machine, which is for basically medium-sized foundry. For the bigger foundries and for green sand, we have gas-fired unit. You see in the top left picture, from left the dedusting unit, then the two drums sitting one on top of the other, and the feeding silo on the right. And this needs about 20 meters length times 3.5 meters in width. All these machines can be placed outside, even in the harsh Finnish winter, so that you don't need to waste any space in your production hall for that machine. You can just place it near your car shop or near your shakeout to run it there. We have all the particulate emissions are so low that the machine can be run, and it's not since it doesn't grind or anything. It's just the main noise emissions are basically the dedusting, the ventilators from the dedusting. For chemical bond sands, we can treat up to 3.5 tons per hour. For green sand, it's a little bit lower because green sand contains normally some moisture, and the sand has to be dried first, and this takes a little bit of the peak capacity. But in the end, we need dry single-grain sand. A magnetic separation unit is included because we don't want to have metal and scrap in the drums. The main thing, if someone wants to run such a sand reclamation system, is that you can test the sand before. RESAND is not an equipment manufacturer. We are a sand process specialists, so you're not buying hardware from us. And then, as you may know from some of the other companies supplying hardware to foundries, they turn the key and say, well, the equipment works, and now it's your turn to find out how to run it. That you get from us, because, of course, you don't want to risk your casting quality by applying unwanted changes to the sand system. You have to be sure that a course work can be handled with your robots, and the tests have to be representative for production conditions. This is why we put production site machine to Germany, because Germany was our first target market after Scandinavia. In Scandinavia, the foundries can bring their sand to the Nutajärvi test center. It can be tested there under production circumstances. But here in Germany, we put a production scale machine to Freiberg University. So the German foundrymen can go there and see what happens to their sand and just see what's coming out of the machine. And then we can run batch sizes of 5 to 10 tons. You can really do casting tests with the reclaimed sand and not just lab tests. It's a production unit. Join on testing. We have all the parameters that can be measured and shared, not only the sand parameters, but as well the exhaust gas parameters, and you can get the sand back for casting and test it in your molds. The Nutajärvi site is a little bit bigger. Here in the top left picture, can you see the mouse? I'm moving there.
Yes, we see.
Easy. Okay, so we have quite a lot of equipment. Here is the silos and the back where we keep the different sand from the different customers. This here is a former glass factory, basically, and there's a lot of different equipment. We have the lab building here in the front, and the offices. And a lot of there we have another a small testing unit. It's electrically heated. It's just for small lot sizes between 50 and 300 kilograms to test in here. And then we have a fully equipped lab where we can, with a small core shooter, we can do the bending strength tests, and we have everything we need here, not only for the production, but for testing as well. We can, in Nutajärvi, in theory, we could do all types, all sand types. In Finland, there is some olivine sands are in use. We could even try we could even treat inorganic bound sands, but we are not offering that to customers. At the moment, we are concentrating on chemically bond sands, mainly for the hand molding and steel casting customers, and for green sand for the larger automotive customers. And when we look at the sand which comes out of the RESAND process, we see basically it's clear and clean, regardless if it's phenolic sand. Before it was black, after it's white. It's resin and furan bond. It's cold box core sand, or it's from the cold box core scrap, or it's bentonite bond sand from the green sand from the green sand molding lines. Everything is efficiently cleaned from impurities and ready to use in the cold box process or in the form making process as well. To get that, we need to get rid of everything which is combustible. So the loss of ignition has to be the measurement for that. It has to be rather low to ensure the hardness of the cores. Fines have to be effectively removed. We don't want to have dust in the sand, especially for the cold box core process. The pH value doesn't have to be too high, because then the binder system doesn't work. So we have to be well below 9 for the pH value, and the electrical conductivity, which basically gives an indication of the soluble ions in that mixture, has to be below 100 microsiemens for the cold box core production. So we can get 3-point bending strengths, which are normally quite close to the new sand quality. And only in very few cases you have to add a little bit more resin or to get the same quality there. The flue gas emissions are measured, and they are continuously controlled in our process. That's in the Nutajärvi side, and we see that all the relevant limit values, we are well below all the relevant limit values for our exhaust fumes. So you shouldn't have a problem with environmental permitting. Sorry. We started with resin bond sand, the Finnish foundries, because only one foundry used green sand. And reclamation of green sand is a little bit more tricky than the reclamation of resin bond sand. In resin bond sand, you just burn off the binders, and that's it. Well, not for alpha set necessarily. There you can do something wrong, and then you get a glassy surface on top of the sand grains. But because of the polyphosphates, but you need to have some more mechanical attrition after the thermal process compared to resin bond sand for the green sand. When we look what our customers demand from green sand reclamation, you see, of course, there's some residual carbon in there. This can be burned, no problem, but you have to control this burning because the carbon has a very fine particle size. And if you apply too much heat in a very short time, there's some risk that the reaction goes out of control. So you have to control the residual oxygen content in your exhaust gases and the oxygen and airflow for the reaction. And then you have basically two types of water in the bentonite. It's a crystal water and structural water, which has to be taken out, and this has to be done with it's not wise to apply too much heat and in a very short time go with a very high heating rate, like in a fluid bed reactor often happens. So you will get you have to avoid that the deactivated loosely wound dead bentonite reacts with the silica grains. So one thing is to make first to dry the bentonite on top of the grains, and then we use quartz phase transition temperature, go above that temperature afterwards, and then the sand grain within the bentonite shell expands, and so the bentonite shell gets brittle, and then it can be removed, because when you then cool the sand down again, the sand grains will shrink, but the bentonite shell will not, so has been loosened. We have to remove the oolitic layer formed during the casting due to heat exposure, which sits rather, which is really difficult to remove. You can, of course, grind it off, but when you grind, you produce silica dust, and you have the risk of destroying the sand grain size distribution with that process. So we found out that really grinding has to be avoided, because we want to use the sand not only twice but 100 times. So sand particle size distribution must be kept constant and optimal for further use in the foundry. We have, of course, some fines in there. We have the detached bentonite and the weakened sand grains, which have to be taken off. And this process has been developed together with the Technical University Bergakademie Freiberg, the Foundry Institute there. And now we have done a lot of process development and optimization, so we can offer reclaimed sand suitable to be used in a cold box core manufacturing. Of course, you can use the sand in the molding as well, but for molding sand, the quality requirements are not as high. What we observed is, because we are taking out some of the fines in the dedusting unit, that the gas permeability is a little bit better than compared to new sand. When we look at the microscopic images, here on the left, you can see there is some of the layers still sitting on top of the sand grains. We have some here, it's open, but it's not removed. but you can see it's not sitting very close. It has been loosened. So what we have here is basically the shell of the bentonite, which can be taken off by secondary attrition, where sand moves against sand, and with that process, you do not affect the sand grain distribution. So we need a mechanical treatment that removes the rest of the clay residues from the sand grain. It's not just a single process, but here the secondary attrition is a bit more important. And then we have a rather clear and image of the used and reclaimed sand. So what do we have in the incoming green sand? Quartz sand content is normally between 65 and 70%. We have some moisture, we have some carbon, we have some active clay, we have dead clay, and we have some quartz fines. And what we get out is basically that quartz sand, again, at 25 to 35% has to be removed in that process. We have been talking to quite a lot of foundrymen, and especially here in Germany, if you want to invest into some equipment and go to a bank and ask for a loan, it'll be difficult to get it. So we decided if we want to place some of our units in the foundries, we have to find another business model which doesn't need so much investment for the foundries. So what we basically do is we offer sand as a service. We service you with our equipment at the site of your foundry. We place it there, but it remains ours, and you pay per ton of sand processed. This means CapEx is as low as possible. And you do not need to discuss with your bank. Maybe just put another silo in there, but that's not 100,000 of euros. And the sand reclamation, the process, and the quality of the sand is our business. So every of our machines can be remotely administrated from our Finnish base in Nutajärvi. All the machines are connected via the internet. We can see and watch the process. We can regulate the process if necessary. And we have some predictive maintenance there as well. So we can see if some of the bearings, for instance, is getting hotter. We can send a technician out to fix a problem before it occurs. And this is another thing which I found very convincing in that Finnish approach, act based on data. It's a digitalization part in there. Sand of a service model means you can focus on the use of sand before the sand is pre-tested, so you know the process basically works. Our hardware is just two different types. All the process adjustments are done with software and process parameters, but not with variants in the hardware. We have tailor-made process parameters for you and your sand quality. We do not need to buy to build different machines. You do not have to do any major investment. You pay for what you use. The service is provided by us, so you don't have maintenance costs, you don't have spare parts costs. We have 100% online monitoring. Sorry. We're our online remote center. People are there 24/7. We will, for each country, have a local service center available because there's no way flying in technicians from Finland to Turkey. So when we enter Turkey, we will act with a local partner who can do the service there. So we have the flexibility to meet your individual needs. This is a picture of the machine at Simpelkamp Foundry in Krefeld, Germany. This is one of the 12,000 tons per year gas-fired unit. In general, the customer is the operator. So in Germany, Simpelkamp was responsible for the environmental permitting on their sites because they have some other machines on the sites and they have an environmental permit already. So it's normally just an extension of that. We take care of the maintenance and servicing, including the process monitoring remotely. And then the customer pays service fee to us and the energy costs he has on site. For the electrical heated machine, the same, but you don't need gas, you just have electricity. So it's rather simple. What's the effect of that? Some people told me, well, we have to bring down our carbon footprint. Our automotive customers demand that. But even with a gas-fired large modular reclaimer, the sand carbon footprint is reduced by about 50%. And most customers we have report of some savings between 10 and 30 euros per ton of sand. How does that happen? When you look at the carbon emissions virgin sand has, a lot of the carbon emissions is in the extraction and processing of new sand. Because the sand normally is washed and then it has to be dried. This is often done with the gas-fired burners. Then you have the end-of-life emissions, and you need, of course, the transportation for the to produce the. Oh, this is wrong here. It's not gas. This is a transportation. Column the top one to bring the sand from the sand mine to the foundry, and to bring the used sand back from the foundry to the landfill. And here we have basically in the recent transportation, we use some our transportation road. There it is. Sorry. And then we have here some, we need natural gas to as a burner for the burners, and we have some carbon emissions from the combustion of the binders. But compared to the average carbon footprint for the new sand, this is about half the carbon dioxide. So we have about 60 kilograms carbon dioxide reduction per ton of sand. Foundries in Europe use more than 7 million tons of virgin sand annually. So there's quite a lot of potential to do something good for the environment. And when you look at the savings, 10 to 30 euros per ton of sand means that you have, when you buy about 10,000 tons of sand per year, which is a capacity of the large reclaimer, this will mean an annual improvement of the annual result by 100,000 to 300,000 euros. You have to sell quite a lot of castings to get an additional result of 300,000 castings. And this is basically our reference list where the machine's running at the moment. It's of course some Finnish customers, Kumera and Valmet. Rahe Valimo, the first customer which is not processed by the sand, which got their own equipment and do not have the processing at Nutajärvi. Suomi Valimo is at, Fundiciones Palacio is the first customer in Spain. And for voxeljet, we are reclaiming some ceramic sands, not quartz sand there, which works as well with our technology. I hope it could give you an overview, 3/4 of an hour, so we have half of our webinar time left for discussions. And my colleague Mikko Immonen has joined me. He's responsible for the market in market areas and especially at the moment active in the Turkish market. Thanks a lot for listening, and I'm looking forward to your questions.
Thank you, Mr. Jung. Thank you. Very interesting approach to sand regeneration, especially from cost saving perspective point of view, and also the reducing the carbon dioxide emissions. Yeah, that's very important. And we have to consider the saving of the world. We have to reduce our consumptions for all aspects, not only sand, but also other aspects. You can close your presentation, or whenever needed, we can open it again. Yeah. Mr. Jung, while my colleagues are answering the satisfactory results of the webinar, I will ask you a question. You have given us two examples. One of them is for coarse sand, the other one is for green sand. And what happened if the ratio is always fluctuating? What is the success of the regeneration?
Between coarse sand and green sand, because you have a varying amount of unused cores, like from the cold box system in your.
Yes.
Yes, that we can handle with our online process control. So we have a little bit to adjust the parameters, because when you burn a pure coarse sand, and the coarse sand maybe I give you an example. Aluminium sand casting is not very common in Turkey, but in aluminium sand casting, we have basically the aluminium is not as hot as iron, so the cold box binders do not burn during the casting process. So we have unused, and the great advantage is that these binders have quite a lot of heating value. So you don't need any gas to process the sand. Once you have reached the process temperature, the energy within these unused binders will be almost enough to keep the process running. So you need very little energy to process that. And when you have fluctuating amounts of cold box sand residues in the green sand, you have to be able, and this is what we can do with our system, to control the amount of oxygen you add to that system in the burning drum. And then you can adjust the process to the different parameters. So we have an online remote control system and the process regulation for that.
Okay, thank you. Mr. Jung, while you are presenting, few questions came, and my colleagues are still asking some more questions. We should start from the first question coming from Torosan Kara. Are you able to see the chat box?
Not yet. Do I have to click somewhere?
Yeah, chat. Just on
Chat. There it is. Yeah.
Yeah. So, do you see the first question coming from Toros Ankara, saying that you mostly focused on production of cores?
Yeah.
Can I can I only use the reclamation scent after it is treated in course, even using green scent instead of new scent?
Yes, of course you can, but coarse scent is to use it in the molds is easier than to use it in the cold box production, because in the cold box core production you have some parameters like the pH value and the electrical conductivity, which have to be properly set. Otherwise, the sand gets hard before it enters the core box. Because when you have a very basic pH value of maybe above 9 or even 10, the reaction, the hardening reaction starts almost immediately. And you can't really shoot the core then get it in the...
Okay, then second question was, the message was from your side. You can use both. That your intention was giving an answer to our question, isn't it?
Yes, you can use it for both. You can freshen up the green sand. Of course you can, because you remove the dead burnt bentonite with the dedusting. And so the sand, which is coming out of the process, will be able to replace the virgin sand for the green sand. We do not need so much secondary attrition if we just want to freshen up the sand. This is basically done in cases where little cores are needed. We have one customer who is producing manhole covers in green sand. They don't use cores. So then we can get a higher capacity with the green sand reclamation, because we can a little bit turn down the throughput time in the system and get a higher capacity, because the target values are a little bit lower than you need for core production.
Okay, thank you. Another question is coming from Ahmet Melih Mantaroğlu. Hello, Mr. Young. Is it necessary to add kaolin, China clay, for alpha set? If yes, what percentage of kaolin needs to be added?
We have some additives in alpha set production. Kaolin can be one solution, because alpha set is a little bit tricky without additives. Maybe possibly, it depends basically on the additives which are used in that alpha set process. But most of our alpha set processes at kaolin. But this is not. This can be done directly in a liquid phase. So it's a suspension of kaolin, which will be added in the feeding system. Our system can handle quite a lot of different additives, and we have a possibility to add what is needed to treat the sand. We have some other, for instance, when you have some phosphates in there, can be necessary to use some additives as well. This really depends not only on the sand type, but only sometimes on the type of additives your binder producer uses.
Okay, thank you.
But this will be determined in the test phase. That we normally do not only get the used sand, but we need a sample of the virgin sand to get a comparison for that, and some of the binders and you use in your process. So we have quite a lot. We have done more than 100 different chemicals in our lab, so we normally know what we need to get this sand with a certain type of binder working in the process. We cooperate with the binder and chemical suppliers normally as well. Of course, in Germany, the most important company is HA. I don't know who is the market leader in Turkey.
HA is one of the big players,
Yeah.
and they are explaining what they are doing in their excellence center in Germany.
Yes, and this is where we normally go to, and that is where we cooperate with them in Bad Deckenstedt in their center of competence. And
Mhm.
this is then we can, because sometimes a small change in the chemicals makes it far more easy to treat the sand thermally, and so we can. But this is something. If there is any difficulty, we have been able to solve everything up to now.
Yeah, surely, surely. So another question is coming from Toro Sankara, asking, what is your suggestion of sand mix rate for cold box? 20/80, 30/70, 50/50.
It depends on the um, shape of your cold box course. If you have rather uncomplicated course with a rather compact, like a ball, you can do it with 100% reclaimed sand. And if it's a cylinder head, I wouldn't go above 50/50.
Yeah, it depends on the shape of the core, you say.
Yeah, basically the shape of the course and the fragility of the course, because you need some the instant bending strength to handle it. And then we have to see what's possible. If you wanted to, normally the average would be 70 reclaimed, 30 new, but it can be higher if you are willing to increase, for instance, the binder content from 0.6 to 0.7. You can go to 80/20 instead of 70/30 or something like this. There's a lot of things you can play around with, and it's basically to see what's the most economical solution. Because more binder and more hardener costs more money. Virgin sand costs more money, so it basically depends on the price ratio what you want to apply. I've seen in some foundry who just used mechanical reclamation. They went up to 1.3, 1.3 for resin and to use reclaimed sand in core production because the quality of that mechanical reclaimed sand was rather poor. But in the end, they were able to get cores out of the core shooters with the reclaimed sand.
Yeah. You did not mention much about the savings on the core binder usage after reclamation, but there is a big saving if everything is proper.
Yes, there is. Because the reclaimed sand with this better gas permeability and a reduced specific surface, normally, especially in the resin bond sand systems, offers you some additional saving there.
Mhm. Mhm. So, Mr. Jung, it seems that there is no more questions. And as we agreed, we will share this presentation with the participants. And for further questions, they will contact you via your email address
Okay.
that is already present in your presentation. And last words for this nice presentation.
Thanks a lot. Thanks a lot for arranging this and giving us the opportunity to present RESAND to the Turkish market, which I believe will have the largest growth rate in Europe in the next years.
Thank you. Thank you. All the best. Thanks once more for your nice, very informative presentation.
And
Bye
if you
bye
want
then.
to share it, feel free. You got a version which is shareable by email. It's just
Yes,
3
I did so.
megabytes. Sure,
Okay.
sure. Possible.
Okay.
There's
Bye
another
bye.
question about
Just came.
just came.
Yeah.
Machines payback time and maintenance frequency. Um, well, the guys doing the construction work at RESAND have a background in ore mining for a large Finnish mining group. And if you are constructing machines for underground mining, you normally do it in a way that you don't have to take them apart and out of the pit again. So we believe normally we do a 5 years contract, and we do not believe that there will be any major issues with our machine during that 5 years. And then we need some need some replacement, like bearings, after these 5 years. But normally that should just work and need a little bit of lubrication. And but all these lubrication values, for instance, are remotely controlled, so we can see if there's some grease missing or anything, or some temperature is rising, and then we can act. So normally we do not expect any really maintenance issues. We will have once a year a maintenance team coming to the site and doing something from the RESAND team. But we hope that we do not have too many emergency actions, because they will eat our profit.
That's true. Do you want to say a few words about the payback time?
No, because
No.
we don't sell the machines.
Okay. You are renting, hiring. Okay. Thank you. Bye-bye then.
Thanks a lot.
All the
Goodbye.
best. Thank you. Hoping to see you sometime in Turkey.
I hope so. I'm happy to meeting.